Hello everyone, how are you today? I hope that all of you are staying healthy. Today we are going to emphasize some more important terms related to vectors. But before that, in the previous lesson you have already learned about vectors and scalar. And in this video, I'm going to show you some important terms related to vectors. Okay, here we have vector addition and subtraction. But before that, we have to recall what resultant is. The resultant is the sum or the combined effect of two or more vectors together. So here I have a picture of vector that is moving in the same direction and opposite direction. So let us try to calculate this vector together. Okay. So for this problem, this is really simple because for the vector that is moving in the same direction, you just add them together. For example, 6 meters plus 4 meters, so you will have 10 meters. And for the vectors that is moving in the opposite direction, it's simple, just subtract them. For example, this one, 6 meters per second moving to the right side and 10 meters per second to the left side. So for the one that moved to the right will be positive, and for the one that moved to the left will be negative. So we will have 4 meters per second moving to the left, okay? Because this vector is much more bigger compared to this vector. That's why the vector here, the resultant, it will move or pointing to the left direction. Okay, so it's very simple. Okay, let's move to the next slide. And for these problems, when we have two perpendicular vectors, it needs more works in order to solve this kind of problem because you need the Pythagoras theorem and trigonometry. Let us see the problem together. So here, for example, I have a question. What is the resultant vector of a vertical displacement of 4 kilometers and a horizontal displacement of 3 kilometers? So suppose that the blue one here, this is the horizontal component, and the vertical component is this one, the blue color also, 4 kilometers. So you are asked to find the resultant vector, sorry. Okay, and this one is the theta. Theta means the direction of this vector. So the first thing that you have to do is try to find the magnitude of this resultant vector. So in order to find the magnitude, you need the knowledge from math, that is Pythagoras theorem. So let us remember the equation of Pythagoras theorem. Suppose that, wait a minute. This is x, okay? This is x, okay? And this is y. So in Pythagoras theorem, in order to find this r, suppose that this is r, okay? R squared will be equals to x squared and times, sorry. This is x squared plus, this is plus y squared. So this is the equation of Pythagoras theorem. So what you have to do is just plug the number. Here you have x is 3 kilometers and for y is 4 kilometers. Just square them. Okay, let us see for the next slide, for the magnitude. Okay, just plug the number and then take the square root of it, and we will get a square root of 25, so the answer is 5 kilometers. Okay, I think it's clear for you, yeah? 5 kilometers. Okay, and then from here, since this is a vector, so you need to find the direction. You know the magnitude, but now you need the direction. In order to find the direction, you have to find the theta here. So in order to find the theta, again, you need to use math knowledge, that is trigonometry. So let us try to remember what is tangent theta, I mean the equation of tangent theta. So tangent theta here, in order to find the tangent, is opposite divided by adjacent, okay? Maybe some of you say to me, why don't we use sine or cosine? It's okay, it's up to you, because we have already know this magnitude, so you can plug the number. For r is 5 kilometers. But here you can also use tangent theta, it's okay. So tangent theta is opposite divided by adjacent. You have to memorize those equation, okay? So just plug the number, 4 divided by 3, and then take the arc tangent. You can use your calculator, no problem, you can use it. So try to find the arc tangent from this, and it will end up by 53 degrees. So for this resultant vector, the magnitude is 5 kilometers, and the direction is 53 degrees, okay? So this is the way how to solve this problem, this kind of problem. Okay, next, let's move to the next slide. This is also very important, how to find the vector component. So a vector can be separated into perpendicular component given only its magnitude and its angle from one of the component axes. Okay, by using again trigonometry. So let us see together. So suppose that this is our component, okay, x component, y component, and this is the resultant vector. Yes, the vector that we know, 6 meters per second. This is actually, it must be here, 6 meters per second, and this is the theta. So it's actually the opposite with the previous question, okay? In the previous question, you are asked to find the resultant vector, but now you are asked to find the horizontal component and vertical component. So in order to find that, again, here you have to use trigonometry from math knowledge. Okay, so here, if you want to find the horizontal component, you have to keep in your mind that you have to try to recall the equation for cosine theta. So cosine theta can be calculated as adjacent divided by hypotenuse, okay? Adjacent, hypotenuse. Since x is in the, beside the theta, so you have to use cosine, not sine, okay? You have to use cosine. So cosine 60 degrees will be equals to cosine theta, okay? Adjacent divided by hypotenuse. So x divided by 6. So just rearrange this equation. X equals to 6 times cosine 60 degrees. It must be degree here. Okay, so it will be end up with 3 meters per second. This is for horizontal component. What about vertical component? Because we have two components, horizontal and vertical. Vertical component is this y, the green one here. So now please check this y vector is located in front of this theta, okay? In front of 60 degrees. The theta, the angle. So we have to use sine, not cosine but sine, okay? Since for sine theta, the equation, okay, I'm so sorry, this must be in here, okay, so y divided by 6, because opposite divided by hypotenuse, okay? So for sine theta, the equation is opposite divided by hypotenuse. So y divided by 6, this 6 must be here, okay? And rearrange again the equation. So y will be equals to 6 times sine theta. Sine theta, theta is 60 degrees. This must be degree here. And it will end up with 5.2 meters per second. Okay, so these are the way how to solve the problem related to vectors component. Again, I will remind you, this one, the blue one is the horizontal component, and the green one is the vertical component. And for the horizontal component, you use cosine theta, but for vertical component, you will use sine theta. That's, I think that's clear for you. In the next video, I'm going to show you how to solve some problem related to vectors in more detail. That's all from me. If you have any further question, don't hesitate to ask me. Okay, bye-bye.